Hello and thank you for watching my video. My name is Astrid Krasniqi and today we will be covering Chapter 10, Application Layer. This is part of CCNA Semester 1, Introduction to Network. On this chapter is divided in three sections, so objectives for this chapter is Section 10.1, Application Layer Protocols. In this section we explain how the functions of the application layer, session layer, and presentation layer work together to provide network services to end users' applications. Describe how common application layer protocol interact with end user applications. Then we move to section 10.2, well-known application layer protocols and services. In this section we describe at a high level common application layer protocols that provide internet services to end users, including www services and email. Then we describe application layer protocols that provide IP addressing services, including DNS and DHCP. Then we describe the features and operations of well-known application layer protocols that allow for file sharing services, including FTP, file sharing services, SMB protocol. Then we move to section 10.3, the message heard around the world. In here we explain how data is moved across the network from opening an application to receiving data. Okay, section 10.1, Application Layer Protocols. OSI and TCP/IP models revisited. Networking professionals use the OSI and TCP/IP models to communicate both verbally and in written technical documentation. In the OSI model, data is passed from one layer to the next, starting at the application layer on the top on the transmitting host, and proceeding down the hierarchy to the physical layer, and then passing over to communication channel to the destination host, where the data proceeds back up the hierarchy, ending at the application layer. The OSI model layer 5, 6, and 7 are used as a reference for application software developers and vendors to produce products such as web browsers that need to access the network. So if we look at the OSI layer, we are here, we click at the link or something in the network communication. Then our data travels through OSI layers. At each layer adds its own header, and then travel to the destination and travels up the layers to get to the destination. Application layer. The application layer is the closest to the end user. It is the layer that provides the interface between the application we use to communicate and the underlying network over which our messages are transmitted. Application layer protocols are used to exchange data between programs running on the source and destination host. So if we look at the application layer protocols, some of the application layer protocols are like domain name system, DNS, hypertext transfer protocol, HTTP, simple mail transfer protocol, SMTP, dynamic host configuration protocol, DHCP, file transfer protocol, FTP, and internet message access protocol, IMAP. Presentation layer and session layer. The presentation layer has three primary functions: formats or presents data from the source device into compatible form for receipt by the destination device, compression of the data in the way that can be decompressed by the destination device, and then it can encrypt all of the data for transmission and the decryption of the data upon receipt of the destination. Some of the presentation layer protocol like QuickTime, Motion Picture Experts Group, MPEG, Graphic Interchange Format, GIF, Joint Photographic Expert Group, JPEG, Portable Network Graphics, PNG. These are some of the protocols on presentation layer. Then we have a session layer. The session layer handles the exchange of the information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. This layer we call it like a manager layer. TCP/IP application layer protocol. So here we have some protocols that we're going to talk about. First, we have a DNS, domain name system. This protocol resolves internet name to IP addresses. So for example, we remember names much easier than remembering the numbers, like IP addresses. Now, if I give you 10 IP addresses, it will be, you can remember them, but after a while you will start forgetting them. But if I give you 10 names, you're going to remember them for a long time. Then we have a telnet. This is used to provide remote access to servers and network devices or networking devices. Telnet, we use it, for example, when we telnet a router, or telnet a switch, and we start configuring it. Simple Mail Transfer Protocol, SMTP. This protocol transfers mail, messages, and attachments. Dynamic Host Configuration Protocol, or DHCP, a protocol used to assign an IP address, subnet mask, default gateway, and DNS server addresses to a host. So this protocol assigns IP addresses and other information to each host. Hypertext Transfer Protocol, HTTP. This protocol transfers files that makes up the web pages of the World Wide Web. Then another protocol that we have is the File Transfer Protocol, or FTP, a protocol used to for interactive file transfer between systems. Then we have a Trivial File Transfer Protocol, TFTP. This is used for connectionless active file transfer. It's similar to file transfer, it's just connectionless, and it's faster. Bootstrap Protocol, BootP, this is legacy protocol, not used anymore, is precursors to the DHCP protocol. BootP is a network protocol used to obtain IP addresses information during boot up. Post Office Protocol, POP, a protocol used by email clients to retrieve emails from a remote server. And then Internet Message Access Protocol, IMAP. This is another protocol for email retrieval. The difference between POP and IMAP is that POP receives the email, and the email from the server that it's receiving gets deleted. In IMAP, it receives the email, but the email remains on the server still. Peer-to-peer networks. In peer-to-peer networks, two or more computers are connected via a network and can share resources, such as printers and files, without having a dedicated server. Every connected end device, known as a peer, can function as both a server and a client. One computer might assume the role of a server for one transaction, while simultaneously serving as a client for another. The role of a client and a server are set on a per request basis. For example, we look at the peer 1. Peer 1 has a file on the hard disk that is being shared with peer 2. When it's sharing the file for peer 2, peer 1 is the server, and peer 2, when it's accessing that file, is a client. But now peer 1 wants to print something on peer 2. Now is a client to the peer 2 because it's trying to access the printer. So when it's sharing something with another peer, for example a file, when peer 2 is accessing that file, peer 2 is a client, peer 1 is the server. When peer 1 is printing something in peer 2 is the server, peer 1 is the client. So you can see in peer-to-peer networks, both the clients can be, a PC can be both a client and a server. Peer-to-peer applications. Peer-to-peer applications allow a device to act as both a client and a server within the same communication. In this model, every client is a server and every server is a client. Both can initiate a communication and are considered equal in the communication process. However, peer-to-peer applications require that each end device provide a user interface with and run a background service. So when you launch a specific peer-to-peer application, it loads the required user interface and background services. Afterwards, the device can communicate directly. So you can see these two devices are communicating, they send in instant messages to each other. So they both acted as a client and a server at the same time. Common peer-to-peer applications. Each computer in the network running the application can act as a client or a server, we said that, for the other computers in the network running the application. Common peer-to-peer application, we have eDonkey, eMule, Shiraza, BitTorrent, and Bitcoin. Some peer-to-peer applications are based on the Gontella protocol, which enables people to share files on the hard disk with others. So for example, this computer here is looking for some my song MP3, and there's some computers who say, okay, I got it. So they are sharing their documents, the hard drive documents with this client here. Client-server model. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. So in the client-server model, it's more rules are defined. You have a client and you have a servers. Client and server processes are considered to be an application layer. The client begins the exchange by requesting data from the server, which responds by sending one or more streams of data to the client. So a client asks for some data from the server, and the server will respond by sending the stream to the client. When we are getting something from the server, that's considered a download. So when we are receiving a file from the server, it's considered a download. When we are sending a file to the server, it's considered upload.